Hi, I welcome all of you in my channel and in this video in which I am going to perform a two sample t-test for two tails. So let's start the problem. This problem has been picked from Design and Analysis of Experiment book written by Montgomery and 9th edition. So in this question, the question number 2.27, we are going to investigate the two levels of C to F6 on the uniformity of H rate for the silicon wafers. So one of the level is 125 and the second level is 200. It's a flow rate, and we have 6 observation or the response variables at each of the level. So why I have choose the t-test? Because there is no information regarding the standard deviation or variance of the population has been provided. So this is the reason behind selecting of the t-test. Now I will do in this question, I will formulate the hypothesis. After that, I will calculate test statistic. Then we will work on the rejection criteria. Based upon the rejection criteria, we will make decision on the rejection or acceptance of the null and alternate hypothesis. And then I will write the report in the APA format. So let's start this video by formulating the hypothesis. So we will formulate the null and alternate hypothesis. The null hypothesis is represented by H naught, and it is mu1, that mean of the responses at level 125 is equal to mean mu2, where mu2 is the mean of the responses taken at 200 level. Whereas alternate hypothesis represented by H1, where mu1 is not equal to mu2. This not equal to inequality symbol, this is used for the two-tailed t-test. Now I will perform the test statistic. The test statistic for a two-tailed t-test is t naught is equal to y1 bar minus y2 bar divided by sp square root of 1 divided by n1 plus 1 divided by n2, where y1 bar is the mean of sample 1, y2 is the mean of sample 2, sp is the pooled standard deviation, or you can say the combined standard deviation of both the samples. N1 is a sample 1 size, that is 6 observations, and 2 is the sample 2 size, again 6 observations. Now I will calculate y1 bar and y2 bar. Mean is just the addition of all of the observation divided by number of the observation. In order to write the mean, just like this, 2.7 plus 4.6, these are the first two observations in the data. So these are one. And then I will put the three dots, and then I will write the last observation. This is the technical or standard way to write the data when we have too much data or when we have too much observations. Same is the case. I have written first observation plus second observation plus three dots and then plus and the last observation. Please remember this thing while you are solving the assignments or quizzes or exam, because this way you can minimize the writing, as well as you will save the time. However, but please include all those values in the calculator while doing the calculations. So we got 3.317 mean for the sample 1 and 3.933 the sample mean for the sample 2. Now I will calculate the standard deviation or variance for both of the samples. Let's write the formula for the variance. This is the formula for the variance, where we will subtract each individual value, just like 2.7 minus the mean 3.317 for the specific level. Then we will add the second value to 4.6 minus the mean 3.317, take the scale, plus then again I follow the same standard procedure that I have written three dots. I put three dots, then plus sign. Because of the summation sign, we will have to all these values, then the last value 3.8 minus 3.317 whole square divided by n. There are 6 observations, so we will now in this way we calculate the variance. So these are the values of variances for the sample 1 and sample 2. Based upon these two variances, now I will calculate the pooled standard deviation. This is the formula for the pooled standard deviation. So n sample size 1 minus multiply by the variance of sample 1, again plus 6 minus 1 sample size of sample 2 multiplied by variance of the sample 2. N1 N2 are the sample sizes for sample 1. Sample 2 minus 2 is used for the degrees of the freedom, because we lost 2 degrees of freedom in order to calculate this variance. Now I will put all these values in this test statistic t naught, and I will calculate the value. I put all of the values and t naught value comes out to be minus 1.35. Now we will work on the rejection criteria. The rejection criteria, decision making for the hypothesis, and the interpretation of the results as per APA style will be discussed in part 2 of this video. Please watch also that part to get the full understanding of the whole question. Thanks a lot for watching the video. Bye.